My name is David Cox. I'm the director of the MIT-IBM Watson AI Lab, and before that, I was actually a professor at Harvard for 10 years. So I've been in this role for about a year at IBM, and I left academia for this job to run this lab. And what it is it's a joint lab between MIT and IBM, where we work together to chart the future of AI. As a recovering academic, I will say 2017 and before, we were very uncomfortable, the academic community, with the term AI. We really didn't want to call it AI. We didn't call it machine learning, call it deep learning. For some reason in 2018 and beyond, we've all given up and now we're calling it AI. And I think at the end of the day, these are just words. What's really driving this is the excitement around deep learning. So in the last 6 or so years, these technologies have really started taking off. And many of the technologies aren't new, but what's new is the availability of compute and the availability of data that really makes them sing. So we've been seeing tremendous progress, and I think that's what's reignited the excitement around AI, thinking about all the new things we can do, practically speaking, with this new technology. So we work across lots of different problems, but I would say the focus of what we do really is focusing on closing the gaps in what today's AI can't do. So as powerful as AI is today and deep learning is today, it has a number of really important limitations. So one of them, which is one of the most important, is it requires huge amounts of data. And remember, neural networks have been around since the 80s, but they were waiting for that data to come to really make them work. But the problem, yeah, exactly, the internet, digital cameras. But at the end of the day, if you look across enterprise, look at the different problems that people are trying to tackle, a lot of problems in our society, we don't always have that huge amount of data. So as much as people talk about big data and how important big data is, actually small data is really important. How do we take these AI methods and make them work when we don't have a lot of data? And we know that it's possible because we do it. Our brains do it effortlessly. So when my daughter learned what a cat was and what a dog was, I didn't have to show her flashcards of thousands and thousands of cats and go cat, 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 dog, dog, dog. She saw one cat, she called the dog a cat and said, no, honey, that's a dog, and then boom, she's got it, right? So that ability to take single examples and then immediately understand how to generalize, that's something we do effortlessly, and we need our AI systems to be able to do that so that we can tackle all of these hard problems that are happening all over society, all over business. That's how we really unlock the potential of AI. IBM's a leader in quantum. We have some of the best and the first quantum computers. We're in an era right now, it's called the NISQ era of quantum computing, so near noisy intermediate scale quantum computers. So these are kind of the baby quantum computers that are going to eventually give rise to real full-fledged quantum computers in the future. Quantum is an interesting thing. Quantum isn't just faster computers. It's a fundamentally different way of doing computing. So at this stage, we're really just now trying to understand what kinds of problems map well onto quantum computers versus classical computers. And in the MIT-IBM AI Lab, we're asking that question together with our MIT partners. And one of the privileges of working with MIT is we get to work with the very best minds in quantum information science. So there's one famous algorithm in quantum computing called Shor's algorithm, which is an algorithm for factoring numbers. And once we have a universal quantum computer, Shor's algorithm is going to break an awful lot of cryptography. Now, Shor's algorithm is named after Peter Shor. Peter Shor is a professor at MIT, and now we're working with Peter to figure out how quantum and AI are going to interact with each other. What kinds of AI, what kind of AI problems will quantum be well suited to? So we're very excited to explore that area. To be honest, we don't know what's coming, but actually that's half the fun, that's half the excitement, trying to figure out what that future is going to look like. IBM has a long pipeline of technologies. We're the part of IBM that does the long-range research and asks what are the future technologies going to be, but things are just going to keep getting better, keep getting smarter. Something we've built in the near term, Project Debater, is a system that can actually carry on a very coherent debate with a human. That technology is really about how do you empower humans with information to make decisions. So how do you take information from lots of places, construct them into arguments and pros and cons. We think these kinds of technologies are going to start showing up and being available for people to use to help them make decisions. But there's going to be advances across every part of machine learning. So better computer vision, better speech recognition, better natural language understanding. So all of those things are going to keep moving forward.